Hello and welcome to PCMINR.com, and you're watching this video on numerical problems on mechanics by Sonal Gupta. So we have a question which says a ball of mass 0.25 kilograms is attached to a string and it is made to rotate with a constant speed v along a horizontal circle of radius r, which is 0.33 meters. The string is attached to the ceiling and makes an angle of 30 degrees with the vertical. So we are given a situation where they say we have a ball and this ball is attached through a string, and this string has been stretched at an angle of 30 degrees with the vertical, and when it is stretched and released, it starts rotating horizontally like this. It just starts rotating in a horizontal circle, and this horizontal circle makes an angle of 0.33 meters. So the first part of the question, A1, says label all the forces acting on the ball. So you will see that there are only two forces acting on this ball, and we will mark those two forces. The first one is the force of gravity. We call it as actually weight. So you don't write force of gravity, please write weight. So weight, which is equal to mg, that acts downward. We'll mark it here only. Weight mg, that acts downwards. And the force of tension, which is along the string, T. So these two are the forces. If you have to make separately a diagram, you can draw it separately also and show the forces acting like this. And here you can draw a small ball and show that you have labeled it. This is the ball, and you show the tension, which is acting at, of course, 30 degrees with this vertical, and the weight is acting downwards for the ball. Mg is equal to weight. You should mention everything to score full 1 mark. The second part of the question, for A second part, they say state and explain whether the ball is in equilibrium. You don't need to get confused here. The ball is not in equilibrium at all. So we would write our answer, no, the ball is not in equilibrium. And that is because the centripetal force is acting on this ball. The centripetal force acts on the ball, and which changes the direction all the time. So because the direction is changing, so it is an accelerated motion, hence the ball cannot be in equilibrium. So we have to give this argument that no, the ball is not in equilibrium because centripetal force acts on the ball. So the direction of the ball is changing. Direction of the ball is changing, and hence it is accelerated. Therefore, the ball is not in equilibrium. So you will not get any mark if you just write no, the ball is not in equilibrium. You have to give the argument that because the centripetal force acts on the ball, the direction of the ball is changing, and hence it is accelerated motion. Hence the ball cannot be in equilibrium at all. You have to give the right argument. Now when they ask, determine the speed of rotation of the ball in the B part. So we know that it's the centripetal force which is providing it that circular motion. So we would write that mv squared by r is equal to the force responsible for it. And who is providing the centripetal force? That is the tension in the string. So the tension, this horizontal component of the string, the horizontal component of the tension in the string, this one, is providing us the centripetal force. And I hope you know that resolution of vectors. So this component is t sine theta. Though it looks like here horizontal, but actually if you look at the triangle, because the angle is always between the base and the hypotenuse, so t sine theta is the vertical component of the tension in the string. The tension T acts here. So t sine 30 degrees will be the component of the tension that is contributing to the centripetal force, and the horizontal component, which is this way, of the tension, that is T cos 30 degrees. So if you look at this angle is 30 degrees. So if we just take a straight line from here. So this is going to make an angle of 30 degrees again with the vertical. These are alternate angles. So this is 30 degrees. So T cos 30. Now T cos 30 balances the weight. So it's like you have to, figure out the free body diagram. You mark all the forces acting on it. So the tension and the weight are the two forces acting majorly. But we have to split the tension into two components as T sine theta, which is T sine 30, and T cos 30, because it is acting at an angle. And we see that T cos 30 balances out the weight mg. So first we'll find out the tension in the string T, which we can get from T cos 30 is equal to mg. Therefore, what is T equal to? T is equal to mg upon cos 30. Cos 30, the value is root 3 upon 2. Now substitute the values of the mass, which is 0.5. This 2 will go on the top. 2 times 0.25 times g, we'll take it as 10, upon square root 3, which is 1.732. And solving this, we get 2.83 Newton. Now using this value of T, we are going to find out V, because we will get V from this relation as V square is equal to RT by M. Therefore, V, the velocity which we have to find out, is square root of RT by M. So we just focus now on this component, which is T sine 30, and it is providing us the centripetal force. Therefore mv square by r is equal to T sine 30 degrees. T we have already found out. We're just going to substitute the values now. So we get V square is equal to T, we just found out, 2.83 newtons, multiplied by sine 30, which is 1 upon 2, times R, which is 0.33, and upon M, which is 0.25 kilograms. So V square is this, and to find V, we will just put a square root on the right hand side. So we will say V is therefore equal to the square root of this, right? I've just rearranged the terms, and solving all these values, you get 1.4 meter per second as the speed of rotation. I hope this video was helpful. This was an important question from the IB question bank for physics. I hope you've understood how to solve the numerical problems based on the centripetal force and splitting off of the components of forces along the horizontal and the vertical directions. Please follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.